And let's start with Spark. So what is Spark? So Apache Spark, basically it's an analytics engine, and it's especially designed to help you process large-scale data. Uh, the software itself is usually not a single machine, but it's a cluster, and the relationship between the respective nodes in the cluster is that there is always a master, and this master basically knows and has a notion about all the workers, and it keeps the relationships between them. And using this master, you can start your application from a so-called driver. So it can be a separate node. It doesn't have to be a separate node. It can be the same as master, for example. And or you can even run it from any other node in the cluster, because it's just basically a spawn of the application through the master to the workers. And this topology has support for optimal divide and conquer. So basically, it will take your data and divide it to various number of tasks, and then basically these tasks are delegated to respective executors that run on workers, and these executors actually are doing the processing of your data. And then in the end, you have an aggregation phase, and all the data gets returned to the master for post-processing, if you do something like that. If not, then most of the execution happens really on the executor nodes. Spark, or Apache Spark, was written in Java mostly, but despite that, it has very big support for, I would even say, like for any JVM supported language. But the most commonly used languages that people write applications in are Java, Scala, and Python. And recently there is R and SQL as well. Apache Spark is well tested with Scala. We have lots of users and customers that use Spark with Scala. And why do they use it? So that's a big question. Why would you use Spark? So the common use cases or common usages of Spark is, for example, you have like a huge database and you need to do some housekeeping. So you can run this housekeeping job very well on Spark. You want to do some queries, some analytics on top of your data. Yes, Spark will be the perfect engine for that, because it will just basically be able to do it quickly in parallel, and it will be able to aggregate the data for you. So you don't need to write any special framework code. Everything is already in there. And if you leverage Scala and functional programming, it will be a breeze to do it. If you want to do table joins, yes, you can do it on Spark as well. And here I would suggest a little bit more memory on the executors. And then, of course, if you want to do some data enrichment or some transformations or ETL, then you can run it on Spark as well. And of course, basically any task or any job that you can divide into smaller pieces, that's what Spark is for. Spark itself, however, doesn't know how to connect to ScyllaDB. So you have to teach him that. And for Spark to be able to connect to Scylla, you use a thing called a Spark connector. Scylla is Cassandra compatible database, so basically we use the same approach, and the DataStax driver basically works well, and it's a very good start. So feel free to do it, feel free to use it and start it. And we are having in progress a thing which is called the Scylla Shardware driver, and it's not officially out yet. It will be out on the link that I mentioned on the slide. And basically there is a difference on how the data is accessed, and we are trying to optimize from the big difference between the DataStax version and our version is basically a shard awareness. And that means that your application on the query routing level will know exactly what CPU on what node it has to go to for data. While in DataStax version, the application only knows which node or which replica it has to go. With Scylla, it goes even down to the CPU, and then basically it will save you some latency. Let's have a look how you can connect to ScyllaDB. So what works well and what we have very well tested is the Spark cluster ideally on version 2.4. And now I can hear all of you say, okay, but the latest version is 3.0 and 3.1. Yes, we do support 3.0 and 3.1 as well, but those versions are quite recent, and there is not much mileage in there. So if you want to go for something stable, go for Spark Cluster 2.4. Respective to that, or when you will work with Spark 2.4, you should go and always check the correct versions. So basically, I wouldn't recommend to go and use Spark connector 2.2 in Spark cluster 2.4. So there is always an alignment between the Spark version, connector version, JDK version, and underneath basically there is a certain driver version used as well. And you should pay attention to that, and you should basically focus on this because it will make a big difference. And if you use some components that are not ready to work, for example, with latest Spark, or if you use some newer components that, of course, you don't want to use old Spark, and you need to align all these components properly. All this compatibility is written in the link which I have there on the slide. So basically, you can just go and check the version compatibility and compare your version, and be sure to do that because it will save you lots of time and you will avoid lots of troubles. What is good about DataStax builds is that they are in Maven, so they are published, so you can just easily go and include them in your dependencies in your application. Unfortunately, the Shardware drivers are not there yet. So far, once they will be put into the official ScyllaDB repo, then you will be able to have them or consume them from the official Maven sources as well. But so far, you unfortunately have to build them manually. So there's some version. I also pointed you a link there. It points to my fork, which has the shard awareness. You can go and take it. You can build a jar out of there and just use this jar locally and manually, and you will be able to see basically whether it helps you or not. As I said, it's pretty good to start already with the DataStax drivers. And then if you're, for example, if your application is very read heavy and you want to have very good latency for reads, then it will make sense to go to Shardware driver, and you can certainly, or you should certainly try it. It will be worth the hassle when you have to build the jar by yourself. Once you have fulfilled those prerequisites, so basically all your versions are aligned, then you can go to the next step, and the next step is basically configuring all the correct input parameters and have correct imports in your application. So those two steps are also very important. So there is a plethora, and I think maybe even more than 50 of input parameters that you can specify. And for the older version, for the 2.4 connector version, you likely would want to check them all and figure out whether you want to use them or not, or whether the default is okay for your use case or not. And then basically you just go and set them like this. In the newer versions, for example, in Spark 3.0 and 3.1, there is already a notion of catalogs, and datasets have newer version. And there the configuration doesn't have to be so complicated, but you still basically need to specify those configuration parameters, but in a different way, not as you see on this slide, but there is a slightly different way. So that's why I mentioned actually that it's very important which version you pick, because like your mileage and your experience will vary. It won't be a big difference, but there will be a variation on how you use the Spark connector. Once you have the Spark connector, you of course connect to a Spark master, and you can connect to your table, and then you can basically use any data frame or dataset operation on top of the Spark context, or you can even go and directly create a session, and that can be later on seen in the examples. I didn't want to put all the examples into the slides because it just doesn't make sense to write example code here, but I think a very good reference and a very good start is the documentation in the repository itself. So for example, if you want to go for 2.4 or 2.5 connector, you can just go and you can see the first link that is on this slide, and there is a reference of all the parameters. So the connection parameters, read parameters, write parameters, and you can just go and check them all and see whether it makes sense to change them. And then The example of how you can connect is also very well documented, and you should read it from the appropriate version. So always, if you work with Spark 3, go and look at the Spark connector 3. If you work with Spark 3.1, go and look at the connector Spark 3.1, and those documentations will definitely be different. So make sure to always verify that you are looking at the correct version. In the second link, this quick start, there are like follow-up documents, and you can just click through them at the end of every single file and go to the next one, or just list the directory documentation and go from 0, 1, 2, 3, blah, 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 until the last one. They will explain and they will show you basically how to leverage all the appropriate ways how you can connect to the Scylla cluster. So the example I shown you on the previous slide, it's something that works well and it's well defined, but as I said, in newer Sparks, it can be more convenient.